Morning, everyone. I'm going to do this in one take. That's my goal. Okay. So I'm going to talk a little bit about trigonometry, and I'm trying to provide a perspective that makes it easier to move forward. Okay. My assumption is that you've already watched. Scroll down here. You've already watched these two videos, which are by Professor Dave, and it gives you a little bit of a background and maybe some perspective on what trigonometry is and how it can be useful. I'm going to restate some of those things maybe in a more familiar way for us, and hopefully it can become a tool that you're comfortable using. Okay. So I'm just going to start right away here and see how this goes. Okay. So one of the cool things about trigonometry is that for our purposes today and in this course, it's going to be everything that revolves around a right triangle. Okay. And in the video, he talked about the connection between a circle, okay, and all the angles within that circle, right? Oops, that's not what I wanted, okay? So if we were to have this here, so this is what Professor Dave did. And he talked about how if you have an angle here, how you could drop down a line here, and then there you go, you have your right angle triangle, right? And then there's a connection between all of these, okay? So yeah, that'll be review if you had a chance to watch that video. I highly recommend you do. Professor Dave, great hair, good shirts, okay? So one of the things that is it maybe a little bit of a challenge to grasp is the relationship between the angles, okay, and the lengths of the sides, okay? Now, you obviously just saw me copy and paste this this triangle, okay? So it's going to be pretty much the same triangle in the sense that the relationships between here, here, and here are going to be the same as here, here, and here. So that means that the relationship between A and B here is going to be the same between here and here. So if we were to divide this A by this B, we'll get a number. If we were to divide this A by this B, we're going to get a number. And these two numbers are actually going to be the same. Okay, they're going to be the same. And hopefully that'll become clearer a little bit later. Okay, that's not what I wanted to do. Get rid of all the red here. Okay. Okay, so we know that, let me take this here. There we go. That if we were to extend this triangle, I'll keep extending it and extending it. Okay, and then this will go down. Okay, this would still be a right angle triangle. That this angle here, we're going to use it as theta. Now, the reason why we use that symbol there is the exact same reason why we use the letter V for velocity, right? A for acceleration, okay, T for time. It's just a symbol and it's going to represent a number, okay? It's going to represent a number, and that number will be the angle, and in our case, it'll be the angle in degrees, okay, which Professor Dave talked about in his videos. Okay, so that's all that means. Sometimes we talk about two different angles, and we might use a different symbol or something along those lines. Okay, but we'll see. So I want to get rid of these. Keep things tidy. Okay. So this angle for these two triangles, okay, the green one and then the one with the red dotted lines, that angle is going to be the same for both triangles. Okay, and there's a few different ways that we can find that angle. Okay, one way is probably the way that we learned in elementary school, is you can take a protractor, right, that has all those numbers, and you could measure it. Okay, and you could take this thing, you could put it on top, and then you could measure that angle. Okay, that's one way. Nothing wrong with that. Another way to do it would be to this one here, is to take the values of the green triangle. So if we knew this length here, so let's say that we knew that this length was going to be A, and this length was going to be B, and then this length was going to be C. If we knew all those lengths, we could do some math with the A, with the B, and with the C, and then we would be able to figure out what that angle is. Okay, we would be able to figure out what that angle is. Now, if we had, it's this color, let's say that we had the values to the big triangle. Okay, so this A would represent the distance from here all the way to here. The B would represent the distance from here all the way to here, and then C, you've already figured out. C would be from here all the way to there. Okay, you could do the exact same math with those values, and you would get the same angle. Okay. Maybe that was obvious to you, but I always kind of thought it was worthwhile driving that point home. It's going to erase all this stuff here, and we're going to talk a little bit about what this math looks like, because that's the part that gets it to be a little bit tricky. Okay, A, B, C, and then we need to bring in the A. Okay, so let's see here. Let's take a look at a new triangle here. So here's our triangle. Okay, I'm still going to use ABC. So A, B, and C. Now, from our previous time together, and probably what you learned in middle school, is that there's already a relationship between A, B, and C, right? So if you only have A and B, you figure out the length of C, right? So I think you know those already. So A squared plus B squared will equal C squared. So if you have two of those three, then you can figure out the one that's unknown. Okay, you know that, and sometimes we're going to be using that, and that's called the Pythagorean Theorem. And you probably know more about the history of that than I can remember. Okay, so there's a few different things that you can do with these numbers. So the angle that we're going to try to be working around is going to be here. Let's just say you know this angle already. Okay, you know the angle. The angle is going to be 90 degrees. It's called a square or a right triangle. Is that right? Okay. And then if you figure out this angle, then by default, you know what this angle is going to be, right? Because all three of those angles you should know already. So if we were to say, okay, so we're going to call this angle 1, then angle 2. This would be angle 3. So angle 1 plus angle 2 plus angle 3 should equal, you should know, 180 degrees. Okay, and that's the same thing as it's, because it's, how would I explain it? It basically turns around 180. If it did all of that, that would be 360 degrees. We learned that from the previous video, right? But it does not do all of that. It goes half of that, right? So it basically starts here and it makes it all the way around back down to here, and that's 180 degrees. Okay, I realized I didn't sound very confident when I was doing that, but had a second thought. Okay, so you should know that all three of those should be add up to 180 degrees. You know that angle 3, which is here, is 90 degrees. So angle 1 and 2 need to add up to 90 degrees. Okay. Anyhow, we'll spend more time on that a little bit later. Just good things to know. Get rid of these. Technology is amazing. All right. So the types of things, because this is going to be our anchor, this is going to be our perspective. So you're going to pretend that you are here, okay, and you are looking around. You can look and see A, you can look and see C, and you can look and see B. Okay, and when you're doing that, all these things like the A, B, and C are going to be named, for the most part, well, A and B anyway, are going to be named with respect to your location. Okay, so this is where you are. Directly opposite from where you are is going to be B. Okay, so believe it or not, B is going to be called opposite. Okay, that's where you're standing and you're looking across, you're looking opposite from you is going to be B. Okay, A is beside you. Okay, and they don't use the word beside. Another word that you can use for beside is adjacent. Oh, I don't know if I know how to spell adjacent. Is that how you spell adjacent? I'm not sure if the S is in there. Okay, let's pretend that that's spelled correctly. I'm a little bit shy here. Let's see here if we can find, nope. Okay, so we're gonna go with that. We're gonna pretend that that's how you spell adjacent, okay? And C will always have the same name, okay? C will always have the same name, because technically C is adjacent to you as well, But because C is a little bit different than A and B in the sense that it's the longest between A and B. Okay? A and B can kind of switch between who's longer and who's shorter. C is consistently the longest. That's called the hypotenuse. See if I can spell it. Hypotenuse. Let's get rid of it. Hypotenuse. Hypotenuse. Okay? So this is what we have. So we have adjacent. Oh, I took out the S this time. We have opposite. And then we have hypotenuse. Hypotenuse. Okay? Okay, I don't think there's an S there. All right. So those are the names of those places. Okay. If you were up here, let's say that you were up here, then A would be opposite. Okay, because this is your friend, and she's looking across, or she's looking opposite at A. Okay, and that would work out nicely because these values are going to be different. This angle might be different. Okay, wonderful. So let's clean this up a little bit. So we have our triangle, which is going to be here. Okay, we have our angle that we're talking about, and then we have our A, and then B, and then C. Okay, now just as a reminder, A represents the length of that side, B represents the length of this side, and C, in a sense, or not in a sense, also represents the length of this side here. Okay, so if you want to find out the angle of this, you would do some math with A, B, or C. Okay, and we know that A is called adjacent. I'm just going to go ADG. Okay, that's going to be A. B is called opposite, and C is called hypotenuse. Okay, adjacent, opposite, and hypotenuse, and that's because we're doing everything from this perspective. Okay, wonderful. So of all the things that you can do with these numbers, there's going to be stuff that you've done before, and then there's going to be a button that you need to hit on your calculator that's going to be new. Okay, so the stuff that you've done before. So we know what adding looks like. We know what subtraction looks like. I'm going to use the old-fashioned one. We know what division looks like, and we know what multiplication looks like. Okay, so if we were to add A and B, you go A plus B. Okay, if you were to subtract A and B, we go A minus B. Okay? If you're to divide A and B, you go A over B. If you're to multiply A and B, you can go A times B. Okay. Now the one that we're always going to be using for trigonometry is going to be the division. Okay, it's going to be the division, and you have a limited number of options. Okay, you have a limited number of options. Okay, so you could have A divided by B. You could have B divided by A. Okay, you could have A divided by C. You could have C divided by A. You could have B divided by C, and you could have C divided by B. Okay, and in this case, there's only three that we're going to use. The other three we won't use just yet. Okay, and then I'll show a way where it's easy to remember. But when you're doing the math that we talked about earlier, remember over here we said we're going to be doing some math. Okay, the math that you're going to be doing is division. Okay, you're going to be dividing the lengths of the sides, and then there's one button you need to hit on your calculator that will do something beyond my understanding, and then it will give you a number. Okay, and that's the number that you want. Okay, wonderful. I'm going to get rid of some of these things. Okay, so what do we know now? We know that our math that we will do is going to be division, and then there's a special button that you will push. Okay, special button that you will push. So we're back. So that button that you will push. So that button that you will push is on your calculator. Okay, and I will need to go to the scientific side, and then you can see. I don't have any way to draw on here. I think nope, there's no drawing on here. Okay, so you can see in the top left-hand corner. So you can see there's two brackets. Right, I'm pushing those now. Bracket, 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 bracket. Okay, let's clear all those off. just below those brackets, you see one is sin, then to the right cos, and then to the right tan. Okay, sine, cosine, and tangent. Sine, cosine, and tangent. Okay, so we're gonna come back to those in a moment because that's the special button that you would push. Okay, so let's see if we go here. So I want to try to remember what those are. So we have sine, we have sine, we have cosine, and then we have tangent. Okay. Now this is the part where you need a little bit of a memorization. Okay. So I'm going to bring down our triangle here. Copy. I'm going to bring that down to here. Paste. Okay, there it is. And then I will clean it up a little bit. Okay, and then we're going to go A. Okay. So you remember when we said earlier that there's a limited number of things that we can do with the value for A, the value for B, and the value for C. And then we said that the only one that we're going to be doing is we're going to be dividing those values, in some way. Okay, so sine is going to be when you divide the opposite value. So in this case, the opposite will be B by the hypotenuse. Okay, and that will be C. Okay, so when you're dividing, so if you're to have the value for B and you're to have the value for C, then you would want to use sine. Okay, you would hit the button for sine. It's not the whole story yet. I'll give you the whole story in a little bit. Okay, and this is something that you just kind of have to memorize. And then for cosine, okay, cosine will not be opposite over hypotenuse. Will not be B over C. It'll be one of the other options. Okay, you only have another option, so it'll be adjacent over hypotenuse. Okay, adjacent over hypotenuse will be cosine. So in this case, that'll be A divided by C. Okay, so for sine, it was the opposite over the hypotenuse. For cosine, it was adjacent over hypotenuse. Okay, so for tangent, hypotenuse has already had a lot of attention. For tangent, it's actually going to be B over A. Okay, opposite over adjacent. Okay, so this one's going to be opposite over hypotenuse, adjacent over hypotenuse, and the bottom one is going to be opposite over adjacent. Okay, let me clean it up a little bit here so it looks somewhat presentable. So we'll do that really, really quickly. Again, this is complete memorization on our part. So sine is going to be whatever the value is that's opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And tangent has no hypotenuse whatsoever. It's going to be opposite over adjacent. Okay? And in this case, if you're standing here, opposite will be here, adjacent is here, and then C will always be hypotenuse. Okay? And Professor Dave said it is kind of a cool way to remember it. Okay? SOHCAHTOA. SOHCAHTOA. And honestly, that works. I've been using it for a long time, 30 years, and it's still it still rings true, right? Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Okay, and that works really, really well. Okay, and now I said I didn't give you the whole story yet. Okay, this theta actually has a value. Okay, and that's the part that becomes a little bit challenging. Is like how do you represent that in math when you're trying to do some of the mathematical functions on the calculator. So I'm going to draw the triangle again. And take a little bit of a step back here. Okay, so we're going to have theta here. Okay. Now, a lot of times you will be given a value A, and you might be given the value B, which means that you can figure out the value C, but the unknown might be the angle. So sometimes the unknown might be the angle theta. And you need to figure that out. And you're experts on that. For example, if we were to, I'm going to go back to this one here because I enjoy it. If I can remember, it's been a long time. Okay, remember how we were given a whole bunch of values and we would just need to figure out the one unknown. Okay, so it's going to be the exact same here. Okay, You might be given A, B, and C, and you need to figure out what the angle is. Okay, that might be one option, one type of question that you have. Okay, sometimes you're going to be given the angle, and you might be given B. Okay? And then they want you to figure out A, or they want you to figure out C. Okay, so sometimes the angle is given, but maybe A or B or C is not given, and you need to figure those out. Okay, much in the same way that you would do here. You just need to figure out how to isolate that one unknown. Okay, so let's take a look. Let's now include the angle. Remember up here I said that this wasn't the full story. Okay, let's include the angle now. Okay, so when they're saying sine equals, remember we said opposite over hypotenuse. Okay, let's take a look at that. Sine equals opposite over hypotenuse. Okay, so in this case, if this is our perspective, in this case that would be opposite over hypotenuse. That would be B over C. So let's take a look at that again. So sine equals the value for B over the value for C. Now remember that these have numbers, right? So B could be a 3, and C could be, have to be bigger, could be a 4, let's just say. Okay, so we know that this is going to have a number. Okay, so sine, now I left the space here intentionally, okay, because we want to include the angle at some point. Okay, so what this is saying is that sine of the angle is going to equal whatever this value is. So 3 over 4, I think that's at 0.75, right? 0.75. So sine of this angle is going to equal this value here. Okay, so with our calculator, pushing the special buttons, we would be able to figure out what that angle is. Okay, you would need to do something. So let's flip it around. Let's say that they give you the angle. Let's say that the angle, we're going to say it's going to be 30 degrees. So what you would do here is that you would take sine, that's hitting that special button, times 30 will equal, and then they probably wouldn't give you that entire value, and you need to figure out what that value is. Okay, so we'll do that in a couple moments and talk about the order that you would punch in your numbers. Okay, and so let's just say, for example, that you had an angle. I'm going to go down to here. Let's say that you had an angle. So find some open. So let's say that this is our triangle. Keep the triangles green. Okay. Your angle is here, and we're going to do it 3 different times. So we're going to say your angle is going to be 30 degrees. And the second time, your angle is going to be 45 degrees. Okay. And then we're going to say that your angle, let's do something 60 degrees. And then when we do one more, your angle is going to be, how about we do like 5 degrees? Okay, we're going to see what values we get. How about I do 75 degrees? So it's going from small to big. So, okay, so we're going to say that we want to find the sine of each. Okay, so the sine of each is always going to be your opposite over your hypotenuse. Now, here's a little bit of here's like a tip. We always know that in this triangle here, right angled triangle, that the hypotenuse is going to be greater than opposite, greater than this side here. It's actually going to be greater than this side here. Okay, the hypotenuse is going to be the longest edge on this triangle. Okay, so if it's opposite over a hypotenuse, which is a small number over a big number, we know that this value here has to be less than 0. Not less than 0, less than 1, sorry. Less than 1, it's going to be less than 1. Okay? It's always going to be less than 1. A small number over a big number. So let's try that. 10 over 20, that gives us 0.5, right? 5 over 6, that'll give us a smaller number than 1. I can't do that, my math isn't that great, okay? So whatever number we get, it should be less than 1 for all of these, okay? Because it's always going to be a small number over a bigger number. So let's take a look. So we're going to do sine 30. What are the steps to get the proper value on a calculator, okay? So even though it says sine 30, you actually type in the number first, 30, and then sine. And there we go, we got a number that's less than 1, okay? There are other types of calculators where maybe you need to punch in the numbers a little bit differently. If you have one of those, you're smarter than me, so you can figure out and see if you get the same value. So we got sine 30 is going to give us 0.5. So here we have, I'm going to put that in a different color. I'm competing with concatenating here, 0.5, okay, which is less than 1, okay? So let's go sine 45. So what that means is that this angle here is going to be 45 degrees. So it's a little bit of a different triangle, okay? And let's see what that number is, okay? So sine 45, go back to my calculator, I hit clear, 45, hit sine, I got 0.707, I'm going to go 0.71, let's just say, okay? Back to notability, 0.7, like I said, 0.71, okay? And that's still less than 1, so we're doing good. Okay, so now we're going to go 60. So now this angle started off at 30, went to 45, now we're at 60, okay? So let's see, so this went 0.5 to 0.71. I wonder what this value would look like. Okay, so we had sine 60, so 60, sine it, 0.87, okay, 0.87, so let's take a look at that. 0.87, so that's less than 1. You can see a little bit of a pattern here, right? You got 0.5, 0.71, 0.87. So the number seems to be going up. So that leads me to believe that sine 75 degrees should be somewhere between 0.87 and 1. That's my guess. Let's take a look here. Okay, so we're 75 sine, and 0.97. Wow, we were right, 0.97. 0.97. So you see all of these numbers were going up as the angle increased, okay? But all of them were less than 1, okay? So from 30 to 75. So that's the order that I would do it on this calculator. It might be different on yours, okay? And what this number says, so what the 0.5 means is that when you take the value for opposite and the value for hypotenuse, that's going to equal 0.5. And you will usually be given one of these values. So that means you can figure out the other one, okay? If the angle was 45 degrees, that would mean that your answer for dividing the opposite value over the hypotenuse value would be 0.71, okay? So they're saying that when you take these two values, you divide them, this is the number that you're going to get, and then so on. So that'll be, it's true for here, it's true for here, here, and here, okay? If you're looking at cosine, or if you're looking at tangent, okay, that just means that you're hitting these other buttons. So you can see where the button for sine is, right? But then it'll be you'd hit cosine, or you'd hit tangent, or something along those lines, okay? Exact same process with this type of calculator, okay? I'm going to stop there because that was quite long, and then I will work on these questions with you a little bit later, okay? Hopefully that wasn't too painful, guys. All right, take care.